Good afternoon, esteemed teachers. I can see that we have many teachers from all across India, spanning across the states of Chhattisgarh, Uttar Pradesh, Jharkhand, Madhya Pradesh, Haryana, Uttarakhand, Rajasthan, and various other states of the nation. I am Aniket Arora, the convener of this session, and I'm honored to moderate this fifth continuous professional development program. This training is brought to you by the Knowledge and Awareness Mapping Platform in collaboration with the CSIR National Metallurgical Laboratory, Jharkhand. As you all know, CAMP is an initiative and knowledge alliance of CSIR NISPER and NCPL, NISA Communication Private Limited. It aims to bridge the gap between education and real-world application, fostering a scientific mindset among students and uncovering their hidden talents. CSIR NML is a leading Indian research organization specializing in minerals, metals, and materials, with a focus on science, technology, industrial services, and human resource development. I would like to extend a special thanks to the dedicated scientists from CSIR NML who are here with us and generously sharing their insights on fostering experiential learning in science education beyond the textbook. Today, we are privileged to have esteemed speakers, including Dr. Sandeep Ghosh Chaudhary, Chief Scientist and Head of Materials Engineering Division at CSIR NML, Dr. K. Gopal Krishna, Chief Scientist of Materials Engineering Division at CSIR NML, and Dr. Animesh Chana, Senior Scientist and PI of Jigyasa, CSIR NML, and of course, our dedicated teachers from all corners of India. Your presence is truly valued as we delve into the theme of fostering experiential learning in science education. Let's make the most of this enriching session as we focus on enhancing our teaching practices for a more experiential and impactful learning experience. Thank you for being a part of this collaborative effort to evaluate the quality of education in our classrooms. But before we proceed with today's session, I would like to mention that recently, on the 15th of February 2024, CAMP organized its 20th scientific excursion at the CSIR Indian Institute of Chemical Technology, Hyderabad, Telangana, where around 150 NASTA students visited and learned from various experts at the CSIR lab. Dr. Vatsala Rani, Principal Scientist and CSIR Jigyasa Coordinator, and her team inspired the students in their scientific pursuits through interactive discussion and lab visit. Within the labs, the students learned several new things in practical manner with respect to anaerobic gas lift reactor technology, water purification technologies, and pheromone technology. This excursion provided the students with a unique opportunity to delve into the world of science, technology, and innovation. It aimed to instill a passion for scientific exploration and discovery within the students. If you would also like your students to participate in such excursions and get a chance to explore, discover, and engage with various scientific disciplines in real-world setting at various eminent CSI laboratories or research organizations in India, then do check out the link below to learn more about how you can participate. For any support, you can even get in touch with our team to the given helpline number in the chat box. Similarly, on the 16th of February, a specialized teacher training program took place at the CSIR IICT, Hyderabad, accommodating over 60 educators from diverse schools. The program focused on the theme enhancing scientific temperament through technological interventions. This event marked CAMP's fourth continuous professional development program tailored for teachers in collaboration with the CBSE. Participating teachers engaged in comprehensive training sessions conducted by subject matter experts covering various dimensions in science education. Through this program, the educators received the opportunity to interact and learn from various scientists and researchers, including Dr. Arvind Chinchure, Chair Professor of the Innovation and Entrepreneurship at the Symbiosis International University, Pune. Dr. Somdata Karak, Science Communication and Outreach Officer, CSIR CCMB, Dr. Jagdish N., Principal Scientist, CSIR IICT, Dr. S. Sridhar, Chief Scientist, CSIR IICT, and Dr. J. Vatsala Rani, Senior Principal Scientist and CSIR Jigyasa Coordinator, CSIR IICT. Moreover, towards the end of the day, the teachers were taken for a lab visit within the CSIR IICT premises, where they learned several new things in a practical manner. If you would like to register for one such training program at your nearest CSIR lab, please check out our upcoming CPD training programs list on our website and feel free to enroll for them. For any support, you can again get in touch with our team through the given helpline number in the chat box. I would also like to inform all the teachers that CAMP NASTA 2023 exam results have been announced for CBSE, KV, and JNV schools. The students can now check the results on our website, www.camp.res.in. My heartfelt congratulations to all the students as they have all done a wonderful job. Well, coming back to today's session, we have with us three expert scientists from CSIR NML, Dr. Sandeep Ghosh Chaudhary, Dr. K. Gopalakrishna, and Dr. Animesh Jana, who will be interacting with you on the topic fostering experiential learning in science education beyond the textbook. Experiential learning is a crucial aspect of science education as it allows us to actively engage with the subject matter, fostering a deeper understanding and appreciation of scientific principles. Now, without any delay, I would like to invite our first speaker of the day, Dr. Sandeep Ghosh Chaudhary, who is Chief Scientist and Head of Materials Engineering Division at CSIR NML. He has been associated with the CSIR NML since 1996 and has gained expertise in the areas of materials development, thermomechanical processing, and crystallographic texture, as well as deformation behavior. Please, sir, can we have you to help us embark on the journey together, committed to fostering experiential learning on science education beyond the textbook?
Yeah. So is it my turn now?
Yes, sir. I'm audible, right? Yeah. You're audible to us?
So I am audible to you people?
Yes, sir. Let me just, can you turn on your video or let me just,
I think you can see me, right?
let me just put you on spotlight. Yes, everyone can see you now.
Well,
Hello,
good afternoon to all the participants, and thanks to the organizers for arranging Jigyasa to join with us with this program for the teachers. Well, we are myself, my colleague, Dr. Gopalakrishnan, and of course, Dr. Animesh Jana, who is one of the co-hosts for this organization, for this program. I think we are from CSIR National Metallurgical Laboratory, Jamshedpur. CSIR, the full form of CSIR is Council of Scientific and Industrial Research, which has nearly about 37 laboratories throughout India. I think you have seen all those IICT, CCMB, which Mr. Aniket Arora was speaking about. I think they are our sister organizations, but of course, they are of different disciplines, mostly biological and life sciences related things, where we work on the materials and the metallurgical research. That is our prime objective for carrying out this kind of work in our laboratory. Our laboratory was established in the year 1950. Out of the 5 first CSI laboratories, our laboratory is the one of them, and it was created just adjacent to Jamshedpur. And Jamshedpur, you might be knowing that it is the first steel city in independent India, or even before independence. The Tata Steel came into its existence here. Tata Steel is more than 100 years old. So to help the industry, because this industrial research, which is a part of the CSIR things, so this part of industry, we have to do the industrial research in a scientific manner. So for that, NML has been placed exactly on just beside the Tata Steel, and Jharkhand, which was a new, very young state of Bharat, but it has a lot of minerals. When you talk about the minerals, we have plenty of minerals like iron, like aluminium, coal. You might be knowing that there are several like Raniganj, Jharia. The coal is completely here in this particular belt, and that's why in the eastern part we have more number of steel plants. Even if you come to this area, you will find that local soil, that soil is not like your normal gray or brown color, rather it is little bit dark reddish, which you will find it out after a iron piece get rusted. So it is basically the iron oxide, which is very much prevalent in the soil of this particular locality. So at NML, we work from this birth to the cradle to the grave. That means we work with the extraction of metals from its ore, the minerals, then its application, and then its debt till performance, of course. And nowadays, another thing which is becoming too important, that we work in the rebirth. That means the recycling of those particular minerals. Like iron oxide. So iron oxide, when there is it is iron and the oxygen. So if I can remove that oxygen from that particular iron oxide, we can get that pure iron. So that's the way the iron is being produced in the steel plants through blast furnace. The equipment which they use it for making this reaction to take place under a certain temperature and pressure conditions, this is known as blast furnace. And that's what they made it, that Fe2O3 plus C, the reaction becomes Fe plus CO2. The CO2 gets emitted from the top, but nowadays there are restrictions on the process. So it is undergoing several such processes to capture that CO2. And this reaction, the Fe plus CO, Fe2O3 plus CO, C is equal to Fe plus CO2, that reaction is exothermic. So the solid iron which is getting replaced, or which is getting precipitated out, that gets melted. And at the bottom of the blast furnace, through which from there we just get the liquid iron, and then we process it more to get liquid steel out of that. So this is one way. Then there are some other elements like aluminium, the mineral from which aluminium is extracted. It is known as Al2O3, alumina. Alumina is basically a very high melting point in the material. So whatever reactions is possible in case of iron oxide, that is not possible for Al2O3, because the temperature is too high for Al2O3 can be dissociated at a high temperature. So what is done is just mixed with another salt kind of thing, some fluoride, and then that can be melted at a lower temperature. And then we use electrometallurgy, which is another discipline, another branch of metallurgy, is that we put electrolytic cell into that. So the electrolytic medium is basically Al2O3 plus that soft fluoride mixture. And then we across a potential with a anode and cathode, and then aluminium comes out in one side and the oxygen goes into the other side. And that's the process. Aluminium comes out from the dissociation of Al2O3. We have another plant very near to Jamshedpur that is known as your Hindustan Copper Limited. But copper ore doesn't come like this. It comes with a sulfide and the copper. And along with that, there is another thing called lead sulfide or zinc sulfide. So there are processes which is known as mineral beneficiation, through which we separate out other sulfides and only the copper sulfide remains. And that through the pyrometallurgy, with temperature, we just eat some reactions, and then copper also gets separated out by pyrometallurgical route. Once it gets this elemental metal is getting recovered, extracted from their minerals, after that, the next step is how to utilize those things. Like you know that gold and silver, they're very soft. Although we make ornaments, but those ornaments are not pure gold or pure silver. We use some other material to give strength to those. Otherwise, those ornaments get dishaped. Like the bangles and all these things. If you sleep or in a different posture, it may get distorted. So that will disturb the whole jewelry aesthetics. Similarly, for these minerals or the elements, metallic elements, they also require some other elements to be alloyed with that to impart strength, to impart various other properties required for that application. You can think of that few days back, Prime Minister Narendra Modi has inaugurated the longest suspension bridge in Gujarat. So this suspension bridge, there are ropes are there. So the ropes are made of this kind of steels. So it should have such a high strength as well as other properties, because it is over the sea. So that means the corrosion properties. And even when there are different kind of amount or different numbers of cars or automotives are moving across that, so then there is a vibration of those things. these vibrations can lead to some kind of a cyclic stress. So that steel or the rope or that steel through which that rope is being made, that should have a sufficient strength to withstand the load of those, that is a static load. Then there are some variation of across that timing, across the day, there is a variation with respect to the car movement. So there is a variation of load, that is the cyclic loading. And also the corrosion aspect, because it is over the sea, that is between your Okha and the Veddaruka. So you can think of that same material has to withstand so many properties which is required for better life of those. Otherwise, we have to replace those wire very frequently, and then making that bridge will be very difficult, or maintenance of the bridge over that sea will be very difficult for us. So to take care of those things, we had to alloy that particular steel, that means iron, with some alloying elements, and then we have to process in the form of thin wire or a wire of a specific dimension, that means diameter. Once this rod is made, after its use, then we don't throw it away. What we do it today, that we just collect in a place those broken wires and all these things, and those are getting remelted in a smaller equipment which is known as electric arc furnace. So, and then we remelt and get another steel from out of that. So it is not only that depth of that element once it is that component is broken, rather this your damaged component or the broken component, that also cut into pieces, and that material, whether it is aluminum, whether it is copper or it's steel, that gets remelted and being reused. Being in the National Metallurgical Laboratory, we also take care of several national priorities. Once we talk about the national priorities, the priorities are which the government decides for the benefit of our country. So nowadays, you might be knowing that in the Paris climate workshop, as well as recently in Dubai, government has told that by 2070, there will be net zero emissions. When you talk about the net zero emissions, see, we talk about net zero emissions. All the blast furnaces, all the power plants, fossil fuel power plants, there is a coal-fired thermal power plants, they generate carbon dioxide. Now, how to take care of this carbon dioxide? There is a ceiling for those things. Today, you might be knowing that weather clock, that if the temperature of the earth increases by 1.5 degree, I think we have nearly about 5 or 6 years still remaining. So that weather clock is there across the India in various places, maybe at your institute also. So we have to be very careful about the emission of CO2. So how to take care of those things? Now you can say, okay, now stop the fossil thermal power plants. But if we close the thermal power plants, then who will give us the energy? Because for our day-to-day life, we require the energy. And India being one of the most populous countries, we require a lot of space and a lot of energy for our people to survive and for the people to have their day-to-day life. So there are processes how to take care of these CO2 emissions. And when you talk about the CO2 emissions, it is the net zero. That means we cannot cut the CO2 emissions, but we'll do some other things so that the CO2 may be captured and CO2 may be stored, so that the net zero, which is getting exposed to the atmosphere, that has zero values. So that intake minus the uptake, that should be zero. That's why it is the net zero emissions. Another priority today, it is coming up because of our various other gadgets, mostly electronic gadgets. When you talk about the electronic gadgets, it is not only your mobile phones and others, but let's talk about that the CO2 emissions, if we can cut down the number of vehicles, because the vehicles are also one of the elements which produces CO2 in a large quantity. So if we can use some battery material, so the electric vehicle, which can reduce the CO2 also. And that way the achieving the net zero emission, that also will be very important. It's easy for the country. So we are also working on various critical minerals. Now, unfortunately, these critical minerals, they are not available in abundance in the earth crust or in India itself. Rather, they are very much rarely available in this, and that's why they are well known as the rare earth elements, and that's why they are also known as strategic minerals. There are very few countries in the world, they have some kind of resources for those things, but that too also in a very low quantity. So from that low quantity, we have to make some kind of a process so that we can generate those elements for our need. When you talk about the forward need, the need for making those batteries. The batteries not only for electric vehicle, batteries for making those our electronic gadgets like mobile phone today, whatever you're using. So that you didn't require to recharge those mobile phones very frequently. So that kind of batteries can you prepare through those elements like neodymium, like the lithium and other elements. So that's why NML, we work not only from these your normal minerals, we also work, which we call it these minerals, that is the primary resources, but we also work from the secondary resources. That means the scraps, that means those your waste products, electronic waste, or any other waste we talk about. Then we also reuse them to save the earth from those CO2 generations, and also to have some resources for our future generations. Thank you very much. I think my other colleague, Dr. Gopala and Dr. Animesh will follow it up with their talks. Thank you very much.
Thank you so much, sir. Thank you. Sorry. Am I audible to you? Hello?
Yeah, thank you.
Yeah. Thank you so much, Dr. Chaudhary, for this enlightening session. I'm sure that the teachers have learned great many things from today, and with these they will gain invaluable insights into the topic. I just have one question: are we going to take question and answer from the teachers right now, or do we take them at the end of the session?
I think at the end of the session would be better.
Sure, no problem. So we'll have that around 4:30.
Okay.
Yes.
Thank you.
Moving on, I would like to invite our next speaker of the day, Dr. K. Gopal Krishna, who is the Chief Scientist of Materials Engineering Division at CSI NML. He has more than 30 years of experience in research and development activities in the area of metallurgical engineering and material science. Currently, Dr. Krishna possesses expertise in the areas of additive manufacturing, material characterization, physical metallurgy, corrosion engineering. Please, sir, can we have you to share your insights upon this topic? Sir, you're on mute.
Hello?
Yes, sir, you're audible now.
Okay. At the outset, let me thank the organizers for giving me this opportunity. Before going for a general discussion, I just wish to make a few slides presentation. Can I do that?
Sure, sir. Yes, sir, please.
I'll just try to share my screen. Just a minute. Are you able to see my presentation?
Yes, sir, we can all.
So, as I understand that we have to discuss on fostering of the learning through experimentation, I just give a science of learning to learning of science. How you can use the science of learning to the benefit of learning science. This is what I would like to present in a few slides, then we can have a general discussion. So, every man-made entity is a first concept in someone's mind. So here I will try to give a set of scientific thoughts for future development, and just I wait a minute. Are you able to see the screen?
Yes, sir, we can see the screen.
but I am having some problem here. Okay. So the difference, are you able to see the animals versus humans slide right now?
No, sir, we can see the preamble, the second page.
Okay. Now let us go here. Animals versus humans. What is the difference between animals and humans? They have strength, we also have strength. They have cooperation, we also have cooperation. They have intelligence. It is known that
Dr.
chimpanzees.
Gopala, can I
Yes,
interrupt you for a minute? I think you are not in the third slide. You are still in the second slide here. Because
not
there
in-
is a small thing is there that is now you change.
now it changed. Okay. Now it is a change. Animals versus
No.
humans.
It is still in the second slide preamble.
Can we try full screen and switching?
You just say that resume slide slow again. Yes.
Yes. Okay. I think now you are seeing the preamble only.
You are still at preamble.
I will leave the first ones.
Or maybe you can unshare and then share it again.
Yes, now we can see. It
Now
has
is
changed.
it visible?
Yes,
Yes,
animal
yes.
versus human.
Sir, it is moving now.
Yes.
Is it okay now?
Yes, yes, sir.
I am in the first slide, science of learning.
Yes, yes, yes.
Now I'm going to animals versus humans. Is it visible?
No, no, sir, it is still
I
in
think there
first
is
slide.
a lag in the system. There is a lag in the network. So that is the reason. Are you able to see now?
No, sir.
Okay, then I will. I think the speed of the network is not good. You are now in still second slide. Is it?
No, sir, first slide.
First one.
That is due to speed problem. This is due to speed.
Now fourth slide.
Moving.
Four.
Okay, okay. Now you are in fourth. Is it
Yes,
okay?
sir. Yes, sir, it is fourth.
Okay. Learning by doing may appear to be proverb, but it is a first step towards perfection. Is it visible?
Yes, sir.
Okay. Let me move to previous slide and whether it is moving or not.
Yes, 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 sir.
It is moving. Okay. Lucky. Thank God. So here I want to stress that humans have imagination, which is not other animals have that characteristic. This is where our learning attitude increases and our learning tendency is enormously improved over animals. So no, but learning by doing, as our topic envisages, we should do learning by doing, which appears to be a proverb in the beginning, but it is a first step towards perfect learning. This, in my opinion. So, why we should learn science? Because this is a very important aspect that when emperors were, when Napoleon was an emperor, he was using aluminum vessels reserved for his essential VIP guests because at that time aluminum was very expensive than other gold and other things. And people he used to serve in gold plates to the servants and others, and aluminum he used to reserve it for VIPs. But present day we have everywhere aluminum vessels in every house. That means we are emperors of those days, is it not? So this who made it this transition? This is a number of scientists, both metallurgists and other material scientists, electrical engineers. Who Hall Herald is the two scientists who invented this process for aluminum recovery. But there are several scientists whose efforts resulted that aluminum we are able to use and day-to-day home now, which emperors used to use only occasionally for VIPs. So science has such a power to make our comforts and essentials requirements we can meet with them. So there are 6 strategies of effective learning, which everyone, most of the teachers will already know, but few for the benefit of for our topic discussion. One is the spaced practice, where you need to spread the study activities over a period of times, like our school and college periods. We have already like that, having different periods in each day, so that you will not study the same subject on the same day forever, all the day. So interleaving, switching between the topics, it is another concept of effective learning. Retrieval practice, bringing out learned info from long-term memory by writing, practicing writing at the learned concepts. Elaboration, why and how work things work, and intrinsic questions about the topic being learned. These are the elaborative discussions which require to understand the topic in a better manner, which is going to take place in every classrooms. Concrete examples are which is very much essential, and this is also mostly taking place. What is missing is dual coding, combining words with visuals, drawings and experimentation. This part is missing in science education especially. So I stress upon this experimentation part, and how experimentation are doing things can make the students perception for science improves and understanding improves, and he will be focused learner for a future scientist. Okay, because most of us, I learned that you are all teachers. You all know about National Education Policy 2020, which is so envisaged for a better, effective learning system for the students with reduced burden on them to by heart. So here, 1 to 8 years is called exposure time. They have to be exposed to various environmental aspects, their lifetime aspects, their surroundings. So this is only just exposure. They should be known to that this is there. There is air, there is a water, there is a like this. But when 8 to 14 years, that is up to ninth class or almost 10th class, you have to experience those things. Visit to science labs comprising basic sciences, understanding science and plays an important role. So here you introduce the somewhat detailed concepts of science, so that the children can get effective inhalation of this what they exposed to now. Now coming to the 14 to 18 years, where we are lacking in most of the schools is that expertise, where they are to be given hands-on expertise in conducting science experiments related to the topics covered till date. Understanding science includes observations and analysis. This concept we have to thrust upon, and there is a lot of efforts by central government also to include one of the some of them including adult tinkering labs, which is government is sponsoring the providing the facilities to the labs. And if somebody wants some related information, they can contact any of the CSR labs and their coordinators for Jignasa and other programs. So they will be exposed to how to handle expert. So by doing conducting experiment, the students will get expertise. So this is what which we are lacking in most of the schools, except few. So what now let us enter into a smart teaching and start learning. What is smart teaching? Teaching is everywhere, and everybody knows about the various methods of teaching from olden days gurukulas, where the students live with the teachers' families, and they used to live in. But right now we have a lot of advantage. Technologies have changed. The learning attitudes have changed. Learning approaches have been changed. So I define smart teaching as a scientific approach for learning experience, where I learned, we already talked about 6 ways of learning. So we should incorporate all the 6 ways of learning into an experience. And media, it should include media, audio visual based teaching, and augmented learning, adopting innovations methods, scientific excursions, student made labs. These are some of the augmented learnings can benefit the students in learning the science subjects. Relating in real time or experimentation, how to relate the learned concepts into real time happenings or real time observations, and do some experimentation to prove the real time observations. And like this it will go on continue, and all these things can be facilitated with the technology enabled. Then IoTs, lot of classrooms, smart classrooms, which everybody knows, most of the classrooms are like that. So, but in this, there is a small glitch. When there is so many benefits, there will be some difficulties also. That is connectivity, the security of the children, the who are exposed to internet. So all these things should be effectively considered, and safety precautions should be taken. That the benefits of only will reach to the children and not the unwanted situations arise where the children are unnecessarily addicted to the smart medias. So it can stop unidirectional teaching and students can interact with the teachers and it can have a double-sided teaching experience. Both. So this unconventional teaching is that it can be a quest-based learning. The children will be interested to learn something, let it be known to us and we will teach them. Quiz-based learning. This can be one kind of a learning aspects where you can put a nice, and science is a very good subject for making this kind of learning approach, quiz-based learning. Concept-based teaching and experimentation to understand, complete learning experience. Healthy competition should be developed instead of only for marks. Marks is only a criteria for qualification of next step promotion, but understanding the science and bringing out healthy competition among the students will be more beneficial and rewarding compared to only marks based evaluations. And the student and teacher should have a friendly environment so that the students will not fear for asking any kind of doubts, including it may be a stupid doubt in the beginning, but it can be once clarified, the student will be enriched with the knowledge in that direction. So motivation forever. We should motivate the children to learn for science subjects as well as why they should learn science. We should continuous motivation required. I will stress upon this point. And you see, one of the university in USA, the students have developed one of the aerodynamic shaped car. It may not be used right now, but it can travel up to 300 miles per gallon. A gallon means around 4.7 liters approximately. So about 5 liters, they travel around 1300 miles, which is a very effective invention by a student team. So when you have all these things, when you have multimedia, when you have everything, the teachers can also relax while teaching, not only on holidays. These are the some of the experiments labs which we can create. I just showed two examples where the resonance is one of the concept where the bridges may fail due to the sound resonating sounds from the nearby these things. So these experiments can be available online, but that can be set up in the in online YouTube. It is available for videos, but it can be set up in the labs for direct demonstration to students. And another aspect which I suggest is that we can have a students on roll to teacher on call. Normally, in every class, every college, we have teachers call for the students on the rolls and take attendance. But in the reverse, it need not be the same forever. And even a teacher, when a student wants some teacher to be called and asked for some doubts, the teacher should be available or made available. It may be anywhere in the world. It may not be from his or her school teacher only. So we need to create an educators database where creation of leading science educators database. The database can be class wise and subject wise. Subdata can be even contain chapter wise expertise. Services can be both online and offline. Recognized expertise other than teachers also can be included so that teachers can students can approach these teachers on their critical understanding to question their quest to realize their quest to be answered. And also we can have a student database so that students roll number and affiliation can be available to the teachers, and who is calling them also should be made available so that the teachers will not be unaware of the persons who are calling and whether they are authentic or not. Then previous performance of the children can be made available so that it can help the students to guide the calibre of the student and can explain accordingly. Participation in science exhibitions can be one of the major concept, and his interest in science subject or choices can also be incorporated into this database. So this is a futuristic idea where every teacher can teach every student and every student can take an expert opinion from another teacher, every teacher. So this kind of creation of these things are already taking place in some countries. Let us hope in India it will start soon. But science is such a subject which requires continuous motivation. Otherwise, people will be interested to think that it is the most toughest subject or it is most complicated subject, and children will move away from the science subjects. So for that, we have to motivate the children towards science, and which is an essential because science can only contribute the scientific contributions last over generations. If you think of a liar can only serve at the maximum 1 or 2 generations. A politician can normally, in general, can serve 1 or 2, 5 to 10 generations. His influence can be there, but a scientific contribution can last over generations to generations. So that is the importance why a child can go for a science studies. Science is essential for advancement of human lives and humankind itself. And science can make life better and comfortable. Science is a universal language. It is not a particular regional or a country specific discipline. It is a universal language. So any development anywhere in the world benefit entire mankind. And science addresses present day demand and also addresses futuristic requirements. And you can see that recently there are some news that one of the tree which is can give 40 types of due to grafting, it can give 40 types of different varieties of fruits. You can think of like this, and in each school if you can have at least one grafted tree which gives 2 fruits or 2 different color flowers, it can be an example for the children to get amusement as well as interest into the science. Invest in today's thoughts. So I will just touch up on how science can in future we influence all our lives. Just I give 1 or 2 examples so that we can all think it is a paradigm. We can like, can we have a personal organ development kits where you have uh, grown from stem cells, a liver, a kidney, and a heart, and stored in your refrigerators. Whenever you want, you can take it to the nearby doctor and ask them to replace it, so that you need not depend on for organ transplantation. So like this, we can think of, and it is happening already. Pigs and all are going to be tested, and that is some places the transformations translate the exercise is fruitful, and it can be nearby future, it can be implementable. So this kind of things can integrate students to learn more towards science, move towards science. Man machine integration, Elon Musk is already working on these areas where you can integrate a chip and download all the, suppose a child is interested in some biology, entire biology knowledge can be transferred to his brain, so that he is known about what is happening today. Then he can start working on what is to be done next 100 years. This can be one interesting idea, that human design. You can design a child, decide the destiny, design the baby, where you can decide the way. In fact, it can be more useful for where children are having problems. They can be treated much before in hand. So like this, you have several ideas where we can think of where science can solve or give an advantage for us in future. And we have brought so many changes into our education. Can we add some more? If possible, let us think and try for it. Else, let us wait and watch. Let the knowledge rise forever with an increment on every sunrise. Science is not a property of single generation. It is a continuous stream through generations. With this, I end my discussion talk, and I will continue to discuss about this. Is my stop sharing? Stop. Is my sharing stop?
No, sir, we can still see your scene. Yes,
Is it
it has
stopped
stopped
now?
now. Yes, it has stopped now.
So now this is what I want to say, that any science education requires 100% theory and as well as experimentation, which is there already in most of the science labs. But I myself, when I was in 8th to 9th classes, I used to visit my paternal uncle, who is having a science teacher and having a very good lab. In those days in a high school itself, we had a college type environment where we have a skeletons, where we have microscopes, where we have biological samples, all those things. So I used to see them and I used to get inspired. So a biological lab or a science lab is very much essential from the school days. This is my first and last point I want to stress upon. And CSR labs are always having a number of labs across the country, where if the students don't have opportunities to have their own labs, they can visit the nearby CSR lab and at least get exposed themselves what science can do and what science does at labs. With this, I will conclude my talk. If any
Exactly.
questions, I can
Yes,
answer.
sure. Thank you so much, Dr. Krishna, for enlightening us. I'm sure that you brought, a valid point that, guiding the students at a very early point enlightens them. It helps them, with the career point, like this is okay, this is what I should be doing. This is my skill set. This is where I can increase. This is where I can land if with my skills as per now. So at the very earlier point, I think CSIR is doing a very great job with Jigyasa for the students. So that is an amazing point that you brought up. Thank you so much. We'll take the question and answer at the end. So we have, last but not the least, we have with us Dr. Animesh Chana, who is a senior scientist and PI of Jigyasa at the CSIR NML. Dr. Jana is an experienced material scientist specializing in two-dimensional functional material such as graphene oxide, borofene, and layered double hydroxide with a focus on applications in energy and the environment. His expertise includes the design and synthesis of adsorbents for heavy metals removal, molecular level design, and synthesis of polymer composites for uranium recovery, and membrane separation process for desalination, wastewater treatment, and carbon dioxide sequestration. Please, sir, can we have you with us to share your insights upon the topic?
Thank you, Aniket. Thank you for this introduction. So, am I audible to all?
Yes, sir, you're audible.
And is my presentation visible to all and the changes?
It's the presentation is visible, but not the changes, I think. Yes, we can see introduction now.
It is changing, na?
Yes, sir, it's changing.
Okay.
Perfect.
So, good afternoon, participants. So, being a Jigyasa PL, we are in touch with schools, teachers, and students as well for inculcating scientific temperament. So, this is one of the flagship program of CSIR to motivate young minds to take the challenges of science and to make a career in STEM. So, in doing so, as per our practiced or older, I would say, system. So the system of transferring knowledge is kind of thing, gathering knowledge is it's unidirectional. So teachers taught us something and we try to mug up or few mug up things, and after that few understandings, then we appeared in the exam and we scored based on our uh, capacity of mind. So how much we remembered actually. So the system is like remembering things. So nowadays it's the educationist they're suggesting that we have to move from this uh, learning science by reading rather than not by learning science by reading, but rather we have to learn science by doing. So that is the experiential learning. So I will talk about these things. So what is experiential learning? So it's referred to the learning through action or learning by doing. So as I told, we have to learn along with the reading by doing also. So if we'll study some concept of physics, so being an educator or being a motivator, I would suggest my students to do the things practically and try to understand the concept. So Confucius in 450 BC suggested that I will quote him that I hear and I forget, I see and I remember, but when I do, I will understand. So that is the basic principle of experiential learning. So Benjamin Franklin in 1750 also stressed upon this fact. So what is the importance of this experiential learning? So rather than focusing on memorizing things, we have to focus on problem solving, critical thinking. So it will also help them to understand or take up the challenges in life other than this uh, careeristic challenges. So if we see that experiential learning, knowing, doing, and to relating, and there is always a feedback and reflection loop, and doing the things will relate and will again gather knowledge and will again reapply the things. So that is the basic fundamentals of experiential learning. So what is the procedure? So there are different steps actually. First step is gathering knowledge, where our educator and teachers are participating and they're doing the jobs fantastically along with this experiential learning. But since experiential learning was little bit in backdrop things, so the time has come to stress upon the experiential learning. So after gaining the knowledge, our next step is to exploring, that is exploring or experiencing, that is by doing. Followed by that, we'll share or reflect what happened, then why it is happened. So the student, curious mind of student will try to find out, try to think about this. This is the ignition that they will think about why it happened and what happened actually. Then they will try to analyze the thing. What is the important concept behind this thing? Why it happened so? Why it is not happened like that? Why it is happened like this only? Then they will generalize the concept. So, and they will try to reapply it in a new concept. So that is the procedural things of this experiential learning. So do, apply and reflect. And this cycle must go on for every concept of science and scientific learning. But there is a big challenges. The knowledge, if we gather knowledge only, there is a particular outcomes. So if I remember this thing, I will write these things, I will get the marks. But in case of experiential learning, the outcome is unpredictable. So student and instruction both may experience success, failure, they may feel adventurous. It is also risk taking, and also a bit of uncertainty would be there. So that will help the student to develop themselves in their life, to take up the challenges of the life. So always they will understand that when problems will come, it may not happen that outcomes will always be predictable. So with this small experiment, they will try to link up the things they have studied in the textbook. So being an educator, our objective would be to motivate them to doing the things and learn the things and reapply the things. All these three things are important. Not only the doing, they have to have some analyzing power. They have to reflect back why it happens, and also when they understood, when they will understand that why it happened, try to encourage them to apply the same concept in different aspect. So it will help them to grow overall. Then being a facilitator or educator, what would be our role? So students nowadays, we live in a generation of open source. So every knowledge is available in Google or any other platforms. So anything you require, you will get some answer from Google. Okay. So our role would be selection of suitable experiments or activities. So you have to map your students in the class based on their thinking level. You have to segregate them, group them, so that you will design some of experiment for some students and some of other experiments for some other students. And then you pose the problems and set some boundaries and tell them where from they will get some answer or clues. That is the support learning, and provide them suitable resources. And we are doing the experiment, we have to think about the safety also. It should be kept in mind that it should be in safe under the safe supervision, and then facilitate the learning process. Then recognize and encourage spontaneous opportunity for learning, engagement with challenging situation, experimentation and discovery of solutions. So giving them a problem, they will try to understand it, they will try to find out solution. By doing so, they will understand, they will learn many things which may not be related to the particular experiment, but maybe uh, helpful for their future. And experimentation, and finally after getting result, they will discover some solution for the said problem. And every time the problem should be interesting, and there we have to think about the problem selections. Then help the learner notice the connections between one context, another, between theory and experience. So not only the theory, but we have to talk about the experiment and the outcomes, and encourage the students to do some activities. So those are the roles of the facilitator. But I know that the participants, they are more into the classroom teaching, they know better than us. So how to teach them? This is only just a few tips from us, how to make the science more interesting to the student. It should not be a burden to the student. They should learn it spontaneously, happily. And the evaluation process should be such that it should not be mug up kind of thing or memorizing things, but it should be based on their critical thinking, analyzing power, and application of their knowledge. So evaluation, that is setting up question, is another crucial things where we should look after. So those are the things we should I wish to highlight. And for doing so, in Jigyasa, we are doing a few small experiment to understand, to teach the students few small things like concept of primary color. So if I'm visible, I will try to show two small things. One is RGB, that is red, green, and blue color. So is it visible?
Yes, sir, it's visible.
Is it visible? So as we know that in class 8, there is a concept of primary colors, and these three colors can be mixed to get any color. Okay. So if you can develop a model, working model, through which they can visualize this. As we know that in watercolor, you can paint and you can mix the color in a ratio, you will get the color. But in classroom teaching, if you want to show them the concept of primary colors and how it is mixing and in what ratio it is mixing to give you some colors, so we have developed this do-it-yourself kit. So this is for the students. So we have red color. This is 100% red. This is 100% green. And this is 100% blue. So if we mix these, what will happen? If we mix 100% red and 100% green, it will turn yellow color. Now, if we reduce the percentage of green, it will be oranges. If we reduce red, so equal proportion of red and green will give you yellow. Then if we switch off this red, it is green, and then we'll add some blue color. So it is a transient sea green, and then a blue color, it will appear. If we switch off red, green, and we'll mix red and blue, you will landed upon pink color or purple color. So through this small experimentation or demonstration, they will understand that how these are the three basic color, and if we mix all these three colors, we will get a white color. So this is one small concept. So through this, you can teach them, and they will never forget. I'm sure that they will never forget this concept of this basic color, primary colors. Okay. Then another concept, a small concept, is electromagnetism. So we have these two parts. We have two separate parts. So there is one copper coil connected with a battery, and we have another copper coil connected with one LED. So these are separated. Okay. So if we switch on this, we'll see that if we keep them in contact, the LED is not actually glowing. But if we switch on this, so if you see, there is a glowing. I'm not sure whether you are able to see it or not, but it is glowing.
We are able to see.
Yeah, you are able to see.
Yes.
So what is happening there? Actually, this is the that is copper loop. Current is flowing through it, and the magnetic field is perpendicular to this. And we have another coil, copper coil, where the magnetic induction will happen and the electricity will circulate through it and will glow the bulb. So that's why it is actually working. Now, what is the basic concept in this? This is the contactless charger. That is, we know that there are contactless charger available in the market. So if you changes the number of turns in the copper coils or the energy source of the battery, so increase the energy source, so you can even transfer more amount of electricity to without connecting these two directly. So this is the magnetic electromagnetic induction. You can easily teach them this kind of concept. So there are many things developed by many CSIR labs in this direction, do-it-yourself kit, through which you will be able to teach them the small concept of physics, chemistry, like that. So physics, chemistry, biology, all those things you can teach them. And these things, by doing these things, if you tell them to fabricate these things by changing the number of turns of copper coils, so they can realize how much electricity is generated, whether the bulb is glowing at a higher intensity or not. So this will help them to learn the concept of this electromagnetism through this experimentation. So this experimentation is very useful and critical in realizing or relating the theoretical knowledge to the practical knowledge. And after getting this knowledge, I will ask the student, so how they will relate these things and whether they will be able to prepare any such kind of model based on this concept or not. So that will complete their application part also. So they will first see this, they will try to analyze it, and after conclusion, they will try to apply this knowledge, reflect back and apply this knowledge for some other application. So through this, we'll be able to generate more curiosity on them, which is the main objective of the Jigyasa, and they will learn the concept effortlessly. So I will stop here, and I think Aniket will say a few words, and then we'll go for this discussion thing. Thank you for patiently listening.
Thank you so much, Dr. Animesh Jana. I really love both your presentations, your presentation as well as Dr. Gopal Krishna's presentation. They're quite simple and easy to understand. I loved it. Thank you so much for enlightening us with the presentation and touching the topic. I think we can move further on to the question and answers. So I'll just say that for the teachers, if you have any question, please raise your hand and we'll connect you one by one.
ये
Okay,
हमने
we
जूम
have
इसमें
first
वो किया है,
question from Kemraj Perwa sir.
तो
Can you
जूम
unmute
हमने
yourself?
इसमें मांगा था कुछ वो करने के लिए, कोई मीट अटेंड करना था हमको प्रोग्राम। तो अब मान लो हो गया, तो इसको उड़ा देना है क्योंकि जूम चाइना का है। ठीक, तो उड़वा देना है, थोड़ा बता देना, हम खुद ही कर लेंगे।
Kemraj sir, can you please unmute yourself? I see your hand is raised, but you're on mute, so we cannot hear your question. Okay, can we move on to the next question then? You can raise your hand if you have any question. I'm not seeing any question from the teachers as of now. I think they've understood all the presentation very well. You can ask any question related to scientific temperament, related to how you can apply these techniques into your classroom. Any questions are welcome. Or you can even write it in the chat box. We can take question from the chat box also. So do you have any question in your chat box, Dr. Animesh?
No, I'm unable
Okay.
to see any question. Chat box.
Because even I'm not getting any questions, I think we can close the session. And in case if you have any question or you would like to get in touch with us, you can drop an email at aniket@camp.res.in, or you can directly connect with our scientists. If you have any question, maybe tomorrow, anytime, you can connect with us.
So please see in the chat.
Okay. Actually, we're not getting anything in the chat as of now. Can you please share the question with me at Aniket Arora or Dr. Animesh Jana or Dr. K. Gopal Krishna? We'd be happy to help you with the answer.
Sir, if we need the teaching learning material, then what is the process to find out that? Are you getting, sir?
Yes, ma'am. Dr. Animesh?
Yes,
Yes, sir.
which
Where can we get the sources?
so which kind of teaching material like what I showed you now?
Yes, sir. Yes, sir.
So these are actually developed by ourselves. So you will not find it anywhere. But if you contact us, we have developed 15 such kind of things like gravitational energy conversion, then magnetic pole detector. Then there are many things. So simple harmonic motion demonstration along with the energy conversion at different levels. So those are with us. So if you wish to get it, so you just write to us or write to Aniket, you will share it to us. We'll send you the concept and the principle of making. So just fabricate it. Or if you are unable, then you tell us. Then we will try to send you one copy of this. Because
Okay,
you will not
thank
find
you,
it there.
Thank you, sir.
So I have one more question from Mr. Khemraj. He wants to know
सर
how.
आवाज की प्रॉब्लम हो रही है
चलो जो
मैं
एग्जाम
audible
है
now?
और क्या करोगे ज्यादा कुछ एक्स्ट्रा करो मत
Okay, I have a question from Mr. Khemraj. He wants to know how to attract students. Like, what are the methods to use in class? I think
क्या एग्जाम
Dr. Jana has wonderfully explained that we can use, practical measures to explain with such technique tools and techniques, such as sources. The students, we can get their attention. We can attract them into more science, and we can explain them practically the theoretical concepts.
Okay. So Gopala sir, are you there?
I'm there. That's what, as Aurora was telling, and Animesh has explained the ways of at the classroom levels. Well, the best way to attract students towards science is to make them to do the experiments, the understanding, the visits to science excursions, science exhibitions, visits to science exhibitions, participation in science exhibitions, interactions with scientists. All these things will make them motivated towards science, and they will try to learn and understand the science better manner. Any addition you can add, Animesh?
So yes, that is the only option to attract students. But I have another opinion like that. So there is two kinds of teaching. One, you teach them and tell them to do. And another option is to tell them to do, try to analyze themselves why it happens. They will understand. So you show them one experiment of say electromagnet. You show them and tell them to find out anything why it happens or like that, and you read it. And in the next class, you start teaching on this. So that will help them to really relate the things before what they understand, because it is already in the back of their mind. They have studied it sufficiently and they will relate it when you will do classroom teaching. So the classroom teaching would be more interesting to them. The only thing is that both way it is acceptable, but the only thing is that we have to make it more enjoyable to the students, so that we need not to tell them to join the class. They will tell us to take the class.
Yeah. Do we have any more other questions?
Good evening, sir.
Good evening.
Meaning,
Uh,
good evening.
I'm Narendra Kumar as a physics teacher. Dr. Jana, sir, you have wonderfully focused on these important points in the classroom, sir. Sir, specifically nowadays as a teacher, what I find the interest of the students somehow lagging because of so many factors. For example, we are talking about technology and all this. And on the other side, the NEP 2020 focuses the reduced curriculum and into the depth of the knowledge of the. But still, on the ground reality, I personally find that what we think out that is not working effectively in the classrooms. So kindly suggest as a teacher, because lot of things I'm connected with you lot of in the parallel terms that physics plays a crucial role for the all these suppose they are going to into the NEET or JEE, they have a very important role when the student think cognitively. But still maybe because there is a lot of awareness, sir, students are visiting the exhibition, they are participating in the science exhibition, they are even involving in the development of the experiments. But still, at the end of the day, that inspire and that spark is somewhere missing. So kindly suggest or guide, because all teachers we are here and you are valuable for us. We will definitely, I will connect with you, sir. Thank you.
So actually, ignition or sparking, it's a continuous session. You will not student will not get sparked overnight by visiting one exhibitions or like that. So the major role would be from your side only, sir. So the thing is that you told that they're more interested on this digital platform, like those things. They have all the mobile phone, Android, or like those things. So we cannot avoid this civilization's demand actually. So better how whether why we are not telling them how to utilize this thing. There are many mobile apps. I am telling you, PHYP one apps is there. Perhaps I will share it to the group, where you can demonstrate many sound experiment. So tell them that this is your laboratory only. You use this as a laboratory, not to see the reels, Instagram reels or Facebook short video like those things. Try to give them interest on those platforms for how they will use it more efficiently for their own learning purpose. So this is one aspect. So because we cannot tell them do not use it, because they will use it. Definitely they will use it. So better to teach them how to use it properly. So that is one thing. Second thing, ignition. So sir, as you told that physics or physics, it is more important for NEET, JEE like things. But as I understand, no subject is important for a single examination. Subject is beyond examination. Subject should be beyond examination. That mindset should be created by teacher as well as it should be inculcated by the parents also. You have, if you love physics, you love physics. It is not for getting good marks and getting good rank in JEE or NEET. If you love physics, you do physics. If you do not love physics, don't do physics. You should not. So that is the thing. It will come slowly in our education system in near future, hopefully. So it is not that if you love physics and you do not get a good rank in NEET or JEE, your career will be finished. So that is not the case. First, that thing they need to understand. And being a teacher, and since you are spending most of the time with them, so it is duty of the teacher or responsibility of the teachers also to guide them in proper career path. So many of the students are facing many stress because of this failure thing, because there is only 11,000 seats in IIT and 11 lakh students are appearing. It is not that all are bad, but because it is not that if you get chance only that you are good in physics, it is also not the case. And most of the students in many students I found in physics classes that they know how to solve the problem because they know what is the formula. Now they don't, most of them do not know the genesis of the formula. And they are also not interested in knowing that, because they know if I know this, I can solve this problem and I will get good marks in exam. So all the learning is based on some exam, targeting some exam. So that should not be a good approach. So you are the most you are making the future of the students, so you have to guide them more profoundly, that do not think it black and white. If you get IIT, you are good, or NIT, you are good. If you are not getting, you are bad. So that black and white thing, from the beginning day, that is when they start thinking about the career, like class 6, 7, 8. From there, you have to inculcate that no, this is not the case. So I think that could be an option, but I don't know whether it will be successful or not, but we can try at least.
Thank you, sir. Thank you. Because you have touched a very minute work, that is the expectation of parents and teachers. Thank you so very much, sir.
Thank you.
Can we proceed to the next question? Do you have any other questions? We can start wrapping up if there are no questions. I think we can start. We have one more question. Okay, we can start wrapping up there since there are no questions.
Okay, shall we stop the session? Close the session?
Yes, I'm just speaking. And
Okay.
so
You-
I just like to thank all the scientists who have dedicated their prestigious time, precious time, and taken up their special time with us and shared the insights on this lovely topic, fostering experiential learning in science education beyond the textbook. As well as I'd like to extend my gratitude to the teachers also who have taken a moment from their busy schedule and attended this session. And I'm sure we have all learned great many things thanks to our scientists.
Thank you for all joining. And we are here, all CSS are there to help you for learning the science effortlessly through Jigyasa program. So try to participate in the program, and it's a throughout the year program, not a single day visit or like those things. So we are always there to help you out, because the future of the nations is in your hand. Thank you.
Thank you so much, sir. Thank
Thank
you. I hope you all enjoyed today's session. This Thursday at 4 p.m., we will be having a 46th online knowledge sharing session for students from class 5th to 12th on the topic Navigating Exams with Confidence and Success by Dr. Komal Parihar, who is an art therapist and co-founder of Ekaki Vedam. I'm sharing with you the link to register for the workshop. Please share it with your students, and you are also welcome to attend the session with your students. In this workshop, the students will get to understand how to manage routine during exams, how to build confidence and healthy habits that will help them succeed and achieve their desired goal. So I'm sharing the link in the chat below. You can all share it with your students. And if you have any further questions or need additional support, be it regarding the scientific excursions that we have every month or the teacher training programs that we have every month, feel free to reach out at any of our social media handles or helpline numbers. Thank you for your active participation and dedication to your personal and professional growth. Now we will end the session, and we will all meet soon for another exciting session by CAMP. Thank you so much again. Thank you.
Thank you.